Let's take a look at how we would configure alarms in Cscape. So to configure alarms, we actually need to start from the graphics editor. So I'm calling up the graphics editor here. As you can see, we have well, it may be obvious to you, we have an XL4 controller that I'm going to be setting up for alarm handling. So from the graphics editor, I'm going to go to Config Alarm. So this is where I do all the setup for alarms or alarm handling as a feature. So the first thing I'm going to do is I'm going to determine how many alarms I want to support. And you can support literally hundreds of them. So I'm going to go ahead in this simple example, I'm just going to go ahead and support 8 alarms. Next, we have to assign a series of bits. Each bit represents one alarm. So in this case, I'm just using the traditional register-based ladder. I'm going to go ahead and use internal non-retentive bits for my alarm status. I could use retentive bits. I could use registers. I have my choice. So in this case, I'm going to go ahead and assign T1025. Notice I used an address that is on a word boundary. So T1, T17, T33, etc. Those are word boundaries, and T25 is as well. Next, I have the option, it's not required, I have the option of assigning 2 additional bits for remotely acknowledging and remotely clearing. So generally, you acknowledge and clear alarms from the screen. So that's typically an operator function. However, let's say you have a SCADA package or some other need to remotely acknowledge or remotely clear an alarm. So you can assign bits here for that purpose. Now, keep in mind that these currently are strictly for acknowledging all the alarms or clearing all the alarms. They're not individual bits for individual alarms. But they're also optional, so I'm not going to assign those here. Next, because we selected 8 alarms, I've got 8 blank, effectively, or default alarms listed here. Alarms 1 through 8. And these will be tied starting at T1025. So the bit that will cause alarm number 1 to turn on is T1025. To turn alarm number 2 on, that's T1026, etc. And we'll show in ladder how those can be, tied to machine conditions in a little bit. All right, so next what I'm going to do, instead of having these generic alarm strings, I'm going to go ahead and type in what these alarms mean in my particular case. So I will double click here on this undefined alarm 1, and let's make that under temp zone 1. Okay, the next alarm will make over temp zone 1. Now, one thing you'll notice, it could take quite a while to type all these alarms in. You do have the option of copying and pasting these to and from Excel. So that can be much faster than doing what I'm doing here. But I'm only doing a few alarms, so I'm going to go ahead and type that in. Let's see, let's make this PSI fault zone 1. All right, I'll type in a few more alarms here. Let's do a motor overload. And lastly, let's go ahead and make this an e-stop trip. Okay, the next concept I want to talk about is the concept of the ability to group alarms. So as you can see here, by default, there's a column showing group 1. You have the ability to create up to 16 different groups of alarms. So if you have a machine with maybe different zones or different functions, and you would like to group your alarms by zone or by function, you have the ability to do that. So as you add alarms, whether it's directly here as I did, or say through Excel with a copy and paste function, you have the ability to assign different groups to different alarms if you choose to do that. In this particular case, I'm just going to go ahead and leave this alone, leave everything in a single group, group 1. Now there's a variety of other things we can configure here, but I think I'm going to come back to that after I've kind of gone through, how you utilize alarms on the screen. Let me go ahead and hit OK here. Now, when it comes to displaying information on the screen in regards to alarms, we utilize what's called the alarm object. So that icon is accessed here. It's the one with a alarm clock icon. And I'm going to go ahead and select that and then click and drag. Okay, so by default, when you use the alarm object and place it on the screen, it creates what we call an alarm window. So that basically is a device or a object that is showing you a few lines of information in regards to alarms. And that can either be what's currently happening with alarms, an alarm summary, or it could actually be what's been happening with alarms or an alarm history. So let's go double click this object and let's configure it. Okay, so the first thing we can configure is, indeed, are we going to configure this device as a summary of current alarms or to show history of what's been happening in the past? So in this case, let's go ahead and make this a summary. Okay, the next thing we can configure is whether we want this alarm object to be a window, as it is by default, or if we just want this to be a button. In other words, okay, we only want to show a quick small button on the screen that by its color will indicate whether there are any alarms or not. So let's go ahead and do that before we configure anything else. Hit OK, and now you can see our alarm window has turned into a button. And in this scenario, we're probably going to configure it something of a more reasonable size that, again, on a screen that has other information on it, allows the operator to see at a glance what's happening with alarms, or at least to see by the color of the object what's happening with alarms. Now, what controls the color? Well, if we go back to our alarm configuration, we can see down here under the summary button colors that when we have no alarms, it's empty, it's going to be green. When we have alarms that have not been acknowledged, it's going to be red. And when we still have current alarms, but they've all been acknowledged, that button is going to be yellow. So again, the function of a alarm button is a small object that at a quick glance allows the operator to see what's going on in general with alarms. Now at runtime, you can actually press this button and then see all the details. Okay, and we'll show you that in the runtime portion of the demo. So here we've configured what we would call an alarm button. And in this case, double clicking again, you can see we've tied that to what's currently happening with alarms by defining it as a summary of current alarms. Okay, a few other options that we can configure. We talked about groups a minute ago. So you can configure which of the 16 groups are included when you're looking at the details for this particular button. And then when an operator presses the button, they're going to see further details of what's happening. And this allows you to configure how that list information is presented, what font size it's in, what format for the date and the time, and if you want the state, is it unacknowledged, acknowledged, in alarm, return to normal, etc. Do you want the state displayed as well? So let's go ahead and wrap that up as an alarm button. Let's go back, select the alarm object again here through this icon. Now this time, let's go ahead and leave this object as the default alarm window. But this time when we configure it, let's configure it for alarm history as opposed to an alarm summary. So this particular object is going to show us the history of what's been happening with alarms. When did they go into alarm? When were they acknowledged? When they were returned to normal, etc. And then the specifics of what, I guess, states are actually recorded here under history. Let's go back again to our alarm config and see where those can be set. So up here in the upper right-hand corner, that's where you have the ability to define for basically a history object, what particular events do we want to record? And then by default, we're pretty much recording them all. All right, one more thing I want to show you in terms of configuration here, and that is you do have the ability to configure a removable media log. So what is this? Well, this is the ability to record what's happening with alarms to a file on your memory card. So I'm going to go ahead and enable that here. All right. You can configure the frequency of when new files are created, and the default is daily. So if you want every day to create a new file with today's alarm history happening, then you could select daily. If you're looking for something weekly, monthly, yearly, you have those capabilities as well. You can define an alarm log path. So let's say that we want this to go in a subdirectory called alarms. And then you can select your time and date format, and as well as your time format here. And then you have a status register that you can define that will allow you to monitor the process to make sure everything is working properly. So that is the alarm log that, again, is optional, that you can make to the removable media card. Next, let's take a look at how these alarms are triggered. Okay, so we've effectively, if we go back to the configuration, we've assigned a series of bits, in this case 8 consecutive bits starting at T1025, that will enunciate alarms. But how do those alarms get tripped? Well, that's where we depend on external events that may be documented in Ladder, for instance. So let's go back into Ladder and take a look at how that might work. So in this area of logic, I have created some simple ladder logic that effectively is defining what causes each of the alarm bits to turn on. So in the case of my low temperature alarm, I'm just checking to see if the temperature that I'm monitoring by the OCS, if it's below the threshold for an alarm, then I'm going to trigger the bit. For a high alarm, similar, but a greater than instruction instead of a less than instruction. In the case of my pressure being out of range, I'm using a limit instruction, which basically says, in this case, if the current pressure is outside of a certain range of limits, and that has occurred for 5 seconds, then I'm going to turn on the pressure alarm bit. In the case of a motor overload, it's strictly a matter of a bit turning on or off that's directly wired into an input. That's going to cause me to effectively turn on the motor overload alarm. And then lastly, an e-stop trip, similar type scenario. So now that we've showed you how to configure alarms, let's go take a look at how they work at runtime. Here's an XL4 running a demo program very similar to what we just configured. I'm looking at an alarm status screen, which contains an alarm button. Now, an alarm button indicates the current status of alarms in terms of its color. So it's currently green, which indicates no alarms. But if I want to see details, I have to actually press the button in order to see details. But at least at a glance, it can show me, do I have any current alarms? Have they been acknowledged? Or is everything normal? I also have, in this example, I have an alarm history screen, which contains a window which shows me details that I can see in this case, for the history of what's happened with alarms. So when they win an alarm, when they return to normal or were acknowledged, those sorts of details are shown, and I don't have to necessarily press the button to see the last few events that have happened. Now, if I want to see a more complete history, then I do have to press that object in order to scroll back through the last, through more than the last few alarms. Okay, let's go back to the status screen and let's go ahead and simulate an alarm condition. So let's say we have an over temperature condition occur. All right, so I'm simulating that here, and you can see that our alarm button has changed from green to red. So that indicates to the operator, hey, you've got a new alarm. So as the operator, if I press that button, I can now see the details. When did that go into alarm? And what specifically is the alarm? In this case, an over temp for zone 1. So typically an operator at this stage is going to go ahead and acknowledge the alarm and escape out of the details screen there. And you'll see that the alarm status button has changed to yellow. So that indicates that yes, we still have an alarm condition, but it has been acknowledged. Now, if we go and take a look at the history, we can see both when the alarm occurred and secondly, when it was acknowledged. That is what the alarm history shows. It kind of records when things occurred, not strictly just what's happening right now. Okay, let's go back to alarm status. And let's go ahead and trigger a new alarm. Let's say somebody presses the e-stop. Okay, once again, it's red. But let's say it's the operator who is pressing the e-stop. So he's not going to acknowledge the alarm because he's busy making an adjustment to the machine with the e-stop pressed. Going to take a look at what's going on with history. We can see, yep, the e-stop has indeed tripped. And then let's say that the operator is done with adjusting the machine and he goes ahead and restores the e-stop to normal. So there you can see we've got a return to normal situation that has occurred. And if we go back and take a look at the status, you'll see if we zoom in there that from a current alarm standpoint, if the operator is the one who put it in, who kind of caused the e-stop and then didn't acknowledge and then went ahead and cleared it again, from a current alarm standpoint, he never really sees it. However, again, going back to history, we can certainly see that that did truly occur. Okay, so that's a quick look at the alarm button and alarm window and how they work at runtime.